Welcome to this mini lesson on the unit circle. Oftentimes when students learn about the unit circle in either Algebra 2 or pre-calculus, the values associated with are just thrown at the students. So this lesson is designed to hopefully explain where the ordered pairs associated with the unit circle come from. So hopefully they'll make a little bit more sense to you. So let's start with the angles associated with the unit circle. First of all, it's called a unit circle because the radius of the circle is 1. So one thing that you want to get familiar with is the fact that, for instance, this ordered pair over there would be 1, 0. This would be 0, 1, just one unit straight up. Over on the left, we have negative 1, 0, and down at the bottom, we have 0, negative 1. Now, as far as the angles are concerned, we know that 180 is over here and 0 is over here. It's also 360 degrees. And really everything is just a fractional part of those degree values. So this first one here, right, that's 1/6 of the way around the semicircle. So this is 30 degrees. This one here is 45 degrees. It's a quarter of the way around the semicircle, 1/4. If you take 1/4 of 180, you get 45. And this one up here is 60 degrees. It's a third of the way over to 180. In calculus, however, we're typically dealing in terms of pi and radians. So hopefully you learned that 30 degrees is equivalent to pi over 6. Easy way to remember that, of course, is that 180 is equivalent to pi. So 1/6 of pi is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 360 degrees, of course, is 2 pi. Up at the top of the circle, which is halfway around the semicircle, that's going to be pi over 2. It's half of pi. Down here at the bottom, we have 3 pi over 2. Now, of course, you can have your negative angles, so 3 pi over 2 at the bottom of the circle would be equivalent to negative pi over 2. Pi over 2 at the top of the circle would be equivalent to negative 3 pi over 2. Think of it as like 1.5 pi, 3 over 2 is 1.5. That's an easy way to think of all of your angles in terms of the unit circle. They're all fractional parts of pi. So for instance, this one down here in the third quadrant, this is all the way around the pi and then a fourth of the way more. So it's like 1 1/4, which is 5/4. So this is 5 pi over 4. All right, so if you think of everything in terms of fractional parts of pi, this is really, really easy and hopefully will make a lot more sense to you. So let's move on to the unit circle ordered pairs. Now, as we said before, this is the point 1, 0. By definition, a unit circle has a radius of 1. So each of these radii that you see coming from the center of the circle, each has a radius of 1. So what we're going to do is come up with the ordered pairs associated on this unit circle for the main 3 angles in the first quadrant, pi over 6, pi over 4, and pi over 3. And what we're going to be using to develop those are our rules associated with the special right triangles, 30, 60, 90, 45, 45, 90 rules. These are just one way to explain where the ordered pairs come from. There's a lot of other ways. This is one way that I think is the easiest. So let's start with pi over 6. All right, so what we're doing is really concentrating just on this little right triangle right here. All right, we know this radius is 1, and if you think about your rules associated, this is really like a 30, 60, 90 triangle. This would be your 30-degree angle here. 60 would be up here. All right, and if you think about the rules associated with 30, 60, 90 triangles, hopefully you remember learning that the short side of the triangle is always half the hypotenuse. So the short side would be over here, and that height has to be half the hypotenuse. So since the hypotenuse is 1, that of course is a half. The long side would be down along here on the base along the x-axis. And you might remember learning that the long side in a 30, 60, 90 triangle is the short side times square root of 3. So if we do the short side, which is a half, times square root of 3, we have square root of 3 over 2. All right, so in order, if you think of this now being on an xy Cartesian plane, the ordered pair then associated with this point up at pi over 6 is going to be square root of 3 over 2, comma, a half. And that's the ordered pair that you need to know associated with pi over 6. A couple different ways you can remember these. If you just take a look at the right triangle, obviously it's longer along the bottom than it is high. You know, a half is only 0.5, everybody knows that, but square root of 3 over 2, that's equivalent to about 0.866. So you know that in a triangle such as this, the base has to be longer just because of how it's situated. So that means the x-coordinate has to be the larger of the two values. So let's do the next one, pi over 4. So here's your pi over 4. So the triangle we're looking at is this one right here. It's this radius right here. So that's the radius 1. So if we drop our perpendicular to create the triangle, all right, this is a 45, 45, 90 triangle. All right, we know our hypotenuse is 1. And again, if you think about the rules associated with, it's always going to be the hypotenuse, and then it's divided by square root of 2. There's a lot of different ways to do this. You could even do it from Pythagorean theorem. If you think of each of these sides as being x, you know, because we do know they're the same length, you could set up a little Pythagorean theorem for yourself and do x squared plus x squared equals 1 squared. So this is 2x squared equals 1. So if you take the square root, it's going to be 1 over square root of 2. So this one actually has a couple really easy ways to think about it. I think Pythagorean theorem's a really easy way as well. So what it comes down to is, now that you know how long each of those sides are, that corresponds to what the coordinates, the x and the y coordinates, are for that ordered pair. It's just 1 over root 2, 1 over root 2. All right, perhaps you learned it as square root of 2 over 2 and square root of 2 over 2. Of course, that's equivalent. In calculus, we don't worry so much about rationalizing our denominators, though. So that becomes the ordered pair associated with pi over 4. So let's turn now to pi over 6. So pi over 6 is this one up here, or pi over 3 rather, that's 60 degrees. All right, here's our hypotenuse, which is 1, so we're going to drop the perpendicular to make our right triangle. Now this is really the same as the triangle that we saw before with pi over 6, that same 30, 60, 90 triangle. The only difference now is it's this angle here, that's the 60 degrees, and the 30 is the little one up top. All right, so again, if we apply those rules for a 30, 60, 90 triangle, now remember this time this is the short side sitting along the x-axis. It's half the length of the hypotenuse, so this would be a half. This height here is the short side times square root of 3, so 1/2 times square root of 3, square root of 3 over 2. Notice how they're the same values as the pi over 6 triangle, they're just turned around. This is the exact same triangle, except now it's taller, whereas the other one was shorter. So this time, the x value is a half, and the y value is square root of 3 over 2. Again, I try to remember it because this is the tall triangle, So it's the y value that has to be the largest between the x and the y coordinates. So as I like to tell students, if you know those three ordered pairs, you pretty much can do anything related to the unit circle. All right, so here they are in summary. You would pretty much need to know these three and then the four quadrantal points. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. All right, using those, you'll be able to then figure out the ordered pairs that go with all these other ones. Because if you take a look at the unit circle, it's very symmetric. All right, so for instance, this point over here, this one right here, all right, that's going to be 5 pi over 6. It's 5/6 the way around to pi. That's going to be symmetric to this point over here. So as you'll be seeing in the next lesson, when we actually use the unit circle ordered pairs to evaluate trig expressions, you'll know that this point here in the second quadrant is pretty much the same ordered pairs as pi over 6. It's just that now it has a negative x value because it's over in the second quadrant. The y value is the same. And it's that way with all these points that you see on the unit circle. They're all symmetric to each other. So that's why I like to tell students, if you know those three in the first quadrant, and then you know your four quadrantal points, you pretty much can do anything associated with the unit circle. So hopefully this helps explain a little bit where they come from and will help you remember them a little bit more.